7. Existential in. Of the 6 rules of predicate logic that we are eventually going to have, we have now examined only one universal out. In the present section, we add one more to the list. The new rule, existential introduction. Existential in I is officially stated as follows. Existential in I of formula Fn is an available line, where Fn is a substitution instance of formula Fv, then one is entitled to infer the existential formula Vfv. In symbols, this may be pictorially summarized as follows. IFN. Vfv here, 1v is any variable x, y, z. 2n is any name aw. 3fv is any formula, and fn is the formula that results when n is substituted for every occurrence of v that is free in fv. Existential in is very much like an upside-down version of universal out. However, turning O upside down to produce I brings a small complication. In O, one begins with the formula fv with variable v, and one substitutes a name n for the variable v. The only possible complication pertains to free and bound occurrences of v. By contrast, in I, one works backwards. One begins with the substitution instance fn with name n, and one does substitutes a variable v for n. Unfortunately, in many cases, desubstitution is radically different from substitution. See examples below. As with all rules of derivation, the best way to understand I is to look at a few examples. Example 1. Have fbb is fn for x fx. Y phi. Zfz at least one thing is f here, n is b, and fn is fb, which is a substitution instance of 3 different formulas fx, phi, and fz. So the inferred formulas which are alphabetic variants of one another. See appendix can all be inferred in accordance with I. In example 1, the intuition underlying the rule's application is quite straightforward. The premise says that b is f. But if b is f, then at least one thing is f, which is what all 3 conclusions assert. One might understand this rule as saying that, if a particular thing has a property, then at least one thing has that property. Example 2. Have rjk jrs k infer x rxk, y rick, zrzk something rs k infer x rjx, y rjy, zrjz jr something. Here, we have 2 choices for nj and k. Treating j as n, rjk is a substitution instance of 3 different formulas rxk, rick, and rzk, which are alphabetic variants of one another. Treating k as n, rjk is a substitution instance of 3 different formulas rjx, rjy, and rjz, which are alphabetic variants of one another. Thus, 2 different sets of formulas can be inferred in accordance with I. In example 2, letting rb, respects, nj be j and k be k, the premise says that j respects k. The conclusions are basically 2 discounting alphabetic variants. Someone respects k, and j respects someone. Example 3. Have fb and hb here, n is b, and fn is fb and hb, which is a substitution instance of 9 different formulas f1 fx and hx, phi and high, fz and hertz f2 fb and hx, fb and high, fb and hertz f3 fx and hb, phi and hb, fz and hb. So the following are all inferences that are in accord with I infer x fx and hx, y phi and high, zfz and hertz infer x fb and hx, y fb and high, zfb and hertz infer x fx and hb, y phi and hb, zfz and hb. In example 3, 3 groups of formulas can be inferred by I. In the case of the first group, the underlying intuition is fairly clear. The premise says that b is f and b is h, that is, b is both f and h, and the conclusions variously say that at least one thing is both f and h. In the case of the remaining 2 groups, the intuition is less clear. These are permitted inferences, but they are seldom, if ever, used in actual derivations, so we will not dwell on them here. In example 3, there are 2 groups of conclusions that are somehow extraneous, although they are certainly permitted. The following example is quite similar, insofar as it involves 2 occurrences of the same name. However, the difference is that the 2 extra groups of valid conclusions are not only legitimate but also useful. Example 4. Have rkk. K rs itself and for x rxx, y re, zrzz something rs itself and for x rxk, y rick, zrzk something rs k and for x rkx, y rky, zrkzk rs something. Here, n is k, and fn is rkk, which is a substitution instance of 9 different formulas rxx, rkx, rxk, as well as the alphabetic variants involving y and z. So the above inferences are all in accord with I. In example 4, although the various inferences at first look a bit complicated, they are actually not too hard to understand. Letting rb, respects, and k be k, then the premise says that K respects K, or more colloquially K respects herself. But if K respects herself, then we can validly draw all of the following conclusions. C1 someone respects her himself XRXX C2 someone respects K XRXK C3 K respects someone XRKX all of these followed from the premise K respects herself, and moreover they are all in accord with I. In all the previous examples, no premise involves a quantifier. The following is the first such example, which introduces a further complication, as well. Example 5 have XRKXK are something and for YXRX, ZXR something are something here, N is K, and Fn is XRKX, which is a substitution instance of two different formulas XRX and XRZX, which are alphabetic variants of one another. However, in this example, there is no alphabetic variant involving the variable x. In other words, XRKX is not a substitution instance of XRXX, because the latter formula doesn't have any substitution instances, since it has no free variables. In example 5, letting R be respects, and letting K be K, the premise says that someone we are not told who in particular respects K. The conclusion says that someone respects someone. If at least one person respects K, then it follows that at least one person respects at least one person. Let us now look at a few examples of derivations that employ I, as well as our earlier rule, O. Example 1 1xfxhxpr2 fa prairie 3xhxdd4 faha 1, O5 hectares 2, 4, O6xhx5, I example 2 1xgxhxpr2 gb prairie 3xgx and hxdd4 gigabytes hb1, O5 hb2, 5, O6 gigabytes and hb2, 5, and i7xgx and hx6, I example 3 1xrxax rax pr2 ra pr3 rab id4 rab is 5 dd6 xrxa2, i7x rax 1, 6, O8x rax 4, i9 7, 8, I example 4 1xyrxy pr2 ra prairie 3 rab dd4 y ray 1, O5 y ray 2, i6 y ray 4, 5, O7 rab 6, O.